So for this problem, we're going to be drawing a slope field. And what a slope field is it is a graph that kind of gives us an idea of what the original function looks like based on the slope at certain points. So what we can do is we can plug in coordinate pairs, find the slope, because remember dy dx, that means the slope at those coordinate pairs. And then that gives us an idea of what our original function looks like. So I'm just going to jump right in. So let's say we have our x, our y, and I'm just going to make m be, which is, of course, dy dx. So we also want to look for patterns. So if I plug in 0, 0, 0 for y, 0 for x, 0 minus 0 is also 0. So what that looks like on my graph is my slope is equal to 0 at that point. And I just do kind of like just a little dash. That means that at the point 0, 0, my slope is going to be 0. And then let's plug in, let's see, if I plug in 1, 1 or 2, 2, those will also subtract and give me 0. So whenever x is equal to y, or so like what I'm saying here is like y is equal to x, my slope will be 0. So if I have the point 1, 1, my slope is 0. If I have the point 2, 2, my slope is 0. If I have the point -1, -1, my slope is 0. If I have the point -2, -2, my slope is 0, because when you subtract those, the x and the y, you get 0. By the way, I'm just filling out this chart for me, but it is not necessary. As a grader, I will just be looking at your slope field. I will not actually be looking at your chart. Okay. All right, so let's plug in some other points. And again, we're looking for patterns. So let's plug in the point like 1, 0. So if I plug in the 1, 0, I would get 0 minus 1, which is -1. Okay, so my slope is going to be -1. So what does the slope of -1 looks like? So if I were to graph like the line, like go down 1 over 1, my slope would connect those 2 points, right? That is a slope of -1. But again, I'm not actually going all the way here to show like, oh, I'm going down 1 over 1. I'm just doing like a little dash to show that. And then let's plug in 2, 1. So if I plug in 2, 1, 1 minus 2 is also -1. So if I plug in 2, 1, I also get -1. And let's plug in 0, -1. 0 minus -1. I'm sorry, -1 minus 0 is also -1. So you should notice the pattern and why I picked these points to plug in. The points along the diagonal are giving me the same slope. And I realized that from the beginning because I noticed that when I plugged in these points, these were all along the diagonal and I had the same slope. Now, that's not true of every slope field. Every slope field is going to have different patterns. But once you think you find a pattern, test your conjecture, and see if it works out. Let's try 0, 1. If I plug in 0, 1, that would be 1. So that's a slope of 1. So it looks like this. If I plug in 1, 2, 2 minus 1 is also 1, which is a slope of +1. And yes, this does follow the same pattern. So along my diagonals, I have the same slope. All right, so let's test 1, -1. That would be -1 minus 1, which is -2. So my slope is -2. So down 2 over 1, I kind of like connect those points. Down 2 over 1, down 2 over 1. Okay, and then what you should notice is like here I have along this diagonal, I have a slope of 1. This diagonal, I have a slope of 0. This diagonal, I have a slope of -1. This diagonal, I have a slope of -2. Well, what's your other pattern that you should notice is that your diagonals, as you go to the right, your diagonals are decreasing slopes by -1. So I'm going to go down 3 over 1. That looks like that. Down 3 over 1. Kind of looks like that. And then down 4 over 1. So it just gets steeper and steeper as I move to the right. And then likewise, I should get a slope of 2 at -2, 0. So let's plug that in. -2, 0. 0 minus -2 is +2. So that checks out. So I have a +2, +2, +2. And then it's just going to get steeper and steeper. Now it's really hard as you get steeper and steeper to like show that it's getting steeper. So just do your best. but that is my slope field. So again, I'm just plugging in points to figure out what dy dx is at that point. And then I'm just plotting like a little tiny dash to represent that slope. So that's what my slope field looks like. And this should kind of remind you of like if you've ever seen like on the Weather Channel, like a wind map or a jet stream. It's like you have the map of the United States and that kind of shows you like, oh, like you've got like this storm here. And usually it shows you like a direction. And what that means is if like you were to drop a feather, it would head like kind of around in this direction, right? This is kind of similar to that. Is it's showing us if I were to plot a point, which is what I'm going to do. I'm going to plot 0, 0. My slope at 0 is 0. And then as I move to the right, I should be following this slope field. So my slope is going to be -1 here. And then my slope is getting steeper and steeper, right? And it's more negative. So my slope is going negative. So like you kind of want to work with the slope field, and it's not going to be perfect. It's just like all of this is not going to be perfect. It's just an estimation. So it's an estimation of what the original graph looks like. It's not going to be exact. So I'm going to say like, oh yeah, it kind of like looks something like this, where like on this side it's going down. And then on this side, okay, so I've got a slope of 0, but on this side, my slope is +1. So as I go to this side, my slope is heading downward. So I don't want to like cross -1, because somewhere I have a slope of -1. So it's like I'm just kind of showing my approaches and like thinking about like, okay, if I were a leaf in the wind, where is this saying that I will follow? And so it's going to look something like this. Likewise, if I were to graph, a point like up here, so my slope here is +2, and then as I head down, my slope, would look like something like that. So on that side of the this kind of slant asymptote, it might look something like this. So that is what a slope function is. It's an idea, gives you an idea of what the original graph kind of looks like. The problem with slope functions is that when you're doing them by hand, it takes a long time to do a lot of points. And when I'm doing this few points, it's hard to see what it looks like. So I'm actually going to throw this into Desmos for a second so you can actually see a better. As you can see, it will go on forever. We only have -10 to 10, but technically you could have an infinite number of points here. So like here I've got like kind of my movable point. So my slope is 0 at 0, and then as you head to the right, your slope is negative. So I'd be heading downward, and then it just gets more and more steep in a negative direction. And then if I head to the left, my slope is positive, and so it's gonna try to show that again. So it's going to kind of look like this, where like it's approaching, and this is a slant asymptote. It can't really cross that line, because then if it crossed, I would have like kind of a slope of 0, but I don't have any slopes of 0. These are all slopes of +1. So it's going to look something like this. Likewise, if I have a point like here, let's say, my slope is +2. And then as I head to the right, my slope gets steeper and steeper and steeper. And then if I head to the left, my slope is kind of getting less steep, but it's still approaching 1. There's like no way for me to cross this without having like a vertical line, but I don't have any vertical lines to, cross this kind of slant asymptote here. So this is just one example of a slope field. You can have lots of slope fields. You could have like y squared, and it would look something like this. You could have x over y, and hey, that's kind of giving me hyperbolas on either side of the origin. Or I could have like x plus y, and it would look similar to the y minus x because I've just changed one sign. You could have all sorts of things, but the idea is that your slope field. Oh, this one's kind of tricky. This one kind of gives me an idea of what my graph would look like. So my slope is 0, then my slope is 1, then it's like steeper. On this side, my slope is 0, then it's like -1, and then getting steeper. If I were to start here, my slope is negative, and then steep on this side. And then over here, it's going to be 0, and then, negative on this side. So you can Google Desmos slope field generator to check your answers once you've made a slope field. But again, your slope fields are not going to be perfect. They're just going to be, they just give you an idea of what the original graph looks like.